So we're thinking about how to solve this. It has, okay, assuming that we are measuring everything right, CO2 has to be coming from somewhere. There's only two places I can imagine extra CO2 is coming from. It's coming from the atmosphere, which means we're over bubbling it and hyper saturating the water with CO2, which is possible. And it could be coming from a living organism respiring in there, which at this point we pulled all the octopuses out. The only thing that could possibly be left is bacteria in there respiring and raising the CO2. But it seems like a lot of bacterial respiration. But you know what? That would make sense why earlier in the summer it worked to get it down, and now it doesn't.
Why would that make sense?
Because
It's not the same water.
no, it's not the same water, but there's been bacteria growing on the sides. If there's been bacteria growing on the sides of the tank all summer and respiring more and more because we're getting more and more bacteria and other like plankton and other algae and other things in there, and it's all respiring, that makes sense why we couldn't do it at the beginning and can do it now. Or could get down to 400 at the beginning of the summer, and now we can't.
So, to get rid of the bacteria, if there were bacteria growing on the sides of the tank, what do we do?
So we could drain it, we could scrub all the sides down to get everything up there, and then we could use ethanol to wipe down the sides and disinfect it, and then try it again. Actually, what we might be able to do is if we do that, we might try bubbling again, see if just bubbling brings it down. So here's what I want us to try. I think we should drain the tank down. So we got the right idea. You were right, we should drain the tank. We should scrub down all the tank. Take out both the false bombs. Take out the first and the second false bombs. Scrub it down. Take ethanol and wipe down all the sides. Make sure that we clean up the bottom really well. Like just make it like spick and span as much as we can in there. Refill it back up with water and start bubbling it. Let's not drop the acid and drop the base quite yet. And then we start bubbling it, see if just bubbling it comes down. And if that doesn't work, then we drop the acid, drop the base, and see if it'll stay down.
Tank cleaning.
Tank cleaning, that's what we're gonna do. If by the end of, okay, so we're not, at this moment we're not getting any data, but by the end of the summer I know how to maintain a tank at 400 parts per million or microatmosphere of CO2. I'm gonna feel like I've accomplished something so I can get good data next year. Next year. This sucks. We're gonna get good data this year because if nothing else, here in like a week, or like now, I'm just gonna start throwing stuff in like 1500.
Okay.
Yeah. Okay, there we go.
Sounds good.
Sounds good.
Let's go.
Okay.
We were unable to achieve atmospheric carbon dioxide levels in the tank using the acid and base method. So a couple different things we're trying out is one of them, we're thinking maybe there's a good amount of bacteria respiring in our tanks. So I just finished, I drained the whole tank, wiped out all the algae so it's nice and white on the sides there. And then I ethanoled the whole tank like probably twice and maybe 2 or 3 times. And I'm just letting it sit for a few more minutes and then I'm gonna rinse it out with seawater and refill it and bubble until tomorrow. And tomorrow we'll see what we're at. You put a bunch of substrate down there, helps control the alkalinity. It's a part of the filtration process, but we took all the substrate out thinking maybe that was buffering the water a little bit and making it harder to change the carbon dioxide levels. So we took that out already, but then I just took the whole false bottoms out and ethanoled them and rinsed them and everything. So we'll see how this works.
One thing that I can do to make a not so great situation a little bit redeemable is that we can, now that our trials are not working very well with the ruby octopuses, our respirometers are sitting empty at the moment. So what I'm going to do is have Marine run some of the mystery octopuses through the respirometers so we can get some good metabolic rates on them and do some temperature trials with those to see what metabolic rates are at different temperatures. So we're going to see how that goes. Lydia is here, being a veteran of respirometry stuff. Help me throw these in real fast. The idea is that this will only take a couple minutes to do, and then we can be back to writing. Woo! Now have mystery octopuses in the respirometers, which is cool. This is actually the first time. Here's the other one. Everybody glare, 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 glare. I've done respirometry on these guys before, but it's always been kind of like smaller, not that great of respirometers, and now we have them in my best respirometers, so this is good. I'm very happy about this. I'm kind of interested to see what their metabolic rate is going to be. So I was trying to work on the dissection of the Benthocetus leoderma a little bit more, and I dumped a big bottle of ethanol formalin stuff onto the laptop I was using. So I am pulling it apart. I'm going to throw it into a drying oven for a while and see if I can get all that out, or at least dried up, and hopefully it works again after that. So we'll see. Hopefully I don't have to buy a new laptop. So at this point, it's become clear that even if I can get my treatments working, the treatments to go down to 400 microatmosphere CO2, I don't have enough time left in the summer to get my experiments done. Sometimes in science, you just have to make the best out of a bad situation and try something different to get what data you can. And that's what I'm going to be doing now. So I'm going to be taking 5 of my 20 octopuses I have right now, and then just getting them into a control treatment of 750 parts per million CO2, which is what it's coming out of our seawater system as. So just a normal control. And then I'm going to take another 5 of them and put them into 1500 parts per million CO2, which we can do. We've been doing this for quite a while. We did this in previous years, so that's no problem. I know I can do that. I'm going to keep them in there for the rest of the summer, which isn't that long. And then after a while of having them in those treatments, I'm going to be looking at respiration rates at that higher CO2 at 1500 to see how well adapted are those that we put into the higher CO2 and kept at lower CO2. How well adapted are they when we just toss them into that higher CO2? Another thing I want to do with the octopuses from these 2 treatments is look at the changes in gene expression, or what genes are turned off or on or up when these octopuses are forced to deal with this higher CO2. I'm going to do this through this thing called RNA sequencing. And this is something that actually is a lot more accessible to me right now because of the octopus genome that was published just last summer. It makes this type of work about 10 times cheaper than it would have been even a year ago. Unfortunately, to do this, I'm going to need to sacrifice several of these octopuses out of each treatment and harvest organs to do that. I've been thinking around this as much as I possibly can to try to find some way that I can do this without sacrificing octopuses, and I don't really know how I can do that. However, if both these things work, this is going to be a really nice data set for the summer, despite all the problems we've been having.